Hello and welcome to the World of NDE 4.0. My name is Johannes Frana, and today I will talk about the technical core of the fourth revolutions, cyber-physical loop, and how all of those emerging technologies are connected, and mainly the industrial Internet of Things, the digital twin, and also AI. Now, I just want to highlight a couple of key things which actually led to me being involved in NDE 4.0. And the first one was really happening somewhere between 2010 and 2014. During that time, I was approached by some specialists for probabilistic fracture mechanics, and they wanted to involve NDE into their calculation models, or the results of NDE into their models, so that actually, they can improve their models and actually achieve longer lifetimes. And that project actually became really fascinating, and it became really successful, and it had a huge business case actually. And if we think about it, using NDE for probabilistic fracture mechanics, today we would kind of call this NDE for Industry 4.0 or in the NDE 4.0. So this was kind of my start getting into NDE 4.0. Then somewhere around 2017, I started my own company. And in 2018 at the ASNT Fall Conference, I met Rippy Singh. And since then, Rippy and myself, we are really trying to drive that whole NDE 4.0 topic internationally. And today we are here at the first international conference of NDE 4.0. During all of that development we had in regards to NDE 4.0, I once did a survey on what people thought critically about NDE. And I got, for example, this comment: NDT does not have any value at all. It only sorts out parts that in reality are good. I don't want it, and I would never ever do it, but my customer insists on it. I would prefer spending the money into further improvement of my production. Now, I don't agree with that. I see that NDE actually has quite some value, but this is a perception of some of our customers. And I think it gives us quite some insight. A lot of our customers see us as a cost center. But this customer also tells us what he wants to have. He wants to improve his own production. But what he doesn't see, that actually NDT could provide him the measures he needs to improve his production. Let's get started on how we could help this customer to get exactly where he wants to be. Now, talking about NDE 4.0, about Industry 4.0 and so on, it's always the word digital is coming up. But digital, we really have to differentiate between three different terms: digitization, digitalization, and digital transformation. Now, digitization that's really just the conversion of some analog data into some digital data. So taking a sheet of paper, putting it in your scanner, and creating an image out of it. Or taking your audio tape and creating a CD out of it. That's digitization. Digitalization is something which we use to simplify certain processes, specific processes. Like, if we have a Word document, that we use it for search and replace, or using an AI actually to enhance our image recognition or something like that. That's all digitalization. Now, digitization, that's really Industry 3.0 or NDE 3.0. Digitalization, now we are on the way to the fourth. And now we are coming to digital transformation. Now, where digitalization is something you can do within your own company. You can perhaps buy as a product. Digital transformation is really something which requires a lot of different stakeholders working together for the greater good. that's what Industry 4.0 and NDE 4.0 is about. Now, if we think back to what we were doing kind of the last 20 or 30 years, we were using feedback loops to create knowledge. So we were taking some data, we are putting it into some data processing, we're using some computer to do the data processing, we're creating some knowledge, and perhaps finally some action. Then we learn, okay, perhaps we need more data, some other data sources, like you have some financial data, using some different computing, perhaps here having a different entity of data processing, adding more data to it, perhaps adding even an augmented reality platform, adding design data, perhaps even adding an AI. And with all this adding up to the system, yeah, we are finally getting here. And this is also kind of what happened to the core element of the third revolution, which was kind of the automation stack. On the automation stack, what we do is all the way on top, we have the ERP system. In the enterprise resource planning system, we are planning our production. And then that is broken down until we reach the production floor so that our equipment knows what it has to do and our personnel knows what it has to do. Finally, we are collecting all the data from our production floor and condensing it back up into the ERP system. Now, what that means, we need interfaces. We need a lot of interfaces. Now, if I talk about interfaces, think about what I showed before on that feedback slide with all those lines. That's kind of what we have here. In particular, between the SCADA and the PLC system, because we have thousands of PLCs on our production floor. Each one is produced by its own OEM, and each one has its own proprietary interfaces. The second big gap is kind of between the MES system and the SCADA system, because somehow, those two systems are typically not digitally connected. Still, people are using paper routing sheets typically. But if they are already using paper routing sheets to give downstream, now if we have information coming upstream, if we have, let's say, a UT report, what do? We scan it or we print it, we scan it and put it into the MES system. So the data which is stored on our UT report is not getting really into the MES system. It's just an image which is stored in the MES system. So that data is kind of lost. And another problem of the automation stack is it's just production. But we do not start with production. We start with an initial idea for a new product. We start with an initial idea and we are doing some design. We also have a lot of our production in our supply chain management, and we want all of that data from the supply chain management to be integrated. We have some product lifecycle management, some maintenance, structural health monitoring, perhaps even some sensors in our production, and perhaps a cloud somehow connected. Now we are coming to the central idea of the Industrial Internet of Things, which is really the first step towards digital transformation. And that is getting rid of all of those proprietary interfaces we have between those systems, and instead, establishing open interfaces so that every single device can talk with every other single device without any burdens. Okay, now where do we find NDE in this whole ecosystem? We actually, structural health monitoring, that's NDE. Sensors are non-destructive evaluation sensors, kind of. We have a lot of NDE on our production floor. We have a lot of NDE in maintenance, and we have a lot of NDE at our suppliers. But typically what happens is we have all of this digital communication, and then we have the NDE where we print that report and scan it and put it into some system. That's not how it's supposed to be. We need to include the NDE data so that we can give our customers what they want to have. They want to have the NDE data to actually use it for improving their production. So we have to get NDE into the IoT as one of the core players. Now, what the IoT does, we started with this kind of historic picture of a feedback loop. Yeah, and we are getting here with the IoT. But what do we need? We need to give the data structure. We have to make the data machine readable. We have to convert data into information. So how do we do that? Now, showing you this number, I think most of you will immediately know what this number is about. If I just enter 42 into my computer will have no clue what 42 is about. But my computer could start searching the internet, but if I enter 42 into Wikipedia, it will actually give me about 100 hits. So still no clue. And also 42 could be, besides all those Wikipedia hits, it could be the length of a truck, or it could be the gain of the UT instrument. But then comes the question, okay, was it before or after calibration? At which day, which probe, which component, and so on and so on. And what we have to do is to tell the computer not only this number 42, but which instrument it was used with, at which day, so all of that information needs to be associated to that single information. And once we have that, we are converting data to information, and we are making sure that the computer understands what we want him to tell. And then actually the computer will also understand that this is actually the answer to the ultimate question of the life, universe, and everything, at least to Douglas Adams' book, Hitchhiker's Guide to the Galaxy. Now, once we are at that place, once we have the IoT with all the semantic interoperability, we can use this actually for data fusion. And then if we can use all of that fused data actually within a virtual representation of an asset in a digital twin. What we need for such a virtual representation, we need a lot of data. And best is if that data is fused, if that data has all those connections in between. Once we have all of that, we can use that data for data processing and gain a lot of knowledge out of that data. For example, here, gaining a lot of knowledge about myself. And those three here, they really understand the value of data. That's why they're gathering so much data. And if you think about our governments and our insurance companies, they also know why they need all of that data about us. But this kind of a concept of a digital twin, yeah, you need all kinds of data sources. And not just data sources, we need information sources, meaning data with semantic interoperability. We can put that into some data processing. Most likely, we will need some visualization, at least in the beginning, perhaps later on, they can, and we will create some action. Now, we don't only need information, we need information with reliability information. Because no matter which data set we are using, we want to know how reliable it is. If you think about a weather forecast, yeah, in 5 days, sun will be shining. How reliable is that information? I need to know that, or my data processing needs to know that to actually accurately think about that data. Then we are coming to data processing. This can be classical computers, this can be AIs, or this can even be a quantum computer. And then we kind of are plugging in different modules, a module for training, a module for predictive maintenance, a module for probabilistic lighting, and so on. And those modules can perhaps even talk with each other. Then we're using some dashboards, some augmented reality for visualization, and we're creating some action. And best of it, all in real time. Now, digital twin, you can create a digital twin of yourself as shown before, but you can also create a digital twin of, let's say, an inspection system or of a complete enterprise. And what you see here, this blue, the gray box is actually the asset itself, meaning the enterprise in this case, and the blue box around it, that's always showing the digital twin. We can create a digital twin for a production line, for the inspection equipment, for the software, or for the individual inspector. And we can already see kind of a structure in here. Enterprise all the way on the top, and software and inspector all the way on, doing the actual production. On the other side, we are producing something. And we already talked about, if we are producing something, we are starting with an initial idea for a product, which we are then designing, procuring some raw material, producing some components within the supply chain, assembling all of that to a product, operating that product, and coming to an end of life. So what we have is, we have on the one side, we have this nesting structure of our production facility. And on the other side, we have here a thread, the digital lifetime of that asset, which we are producing, which is also called the digital thread. Now, in the beginning of our digital thread, we are talking about, a new type of a product we want to produce. And then once we start with the actual production, we are producing different instances of a certain product. Now, with those digital twins, what we do is we actually take this feedback loop one step further by replacing our proprietary data processing by our digital twins. And this is actually where we really have our AI also included, or our machine learning, our deep learning. Now, such cyber-physical loops, if we look once more onto our value stream we have on our lifetime of the asset we are inspecting, we actually have several inspections during that lifetime. We have an inspection during the initial production. We have several inspections at the owner operators during service intervals, and perhaps we have some inspection at the end of life to kind of get into circular economy. And on those, we can use the data we are creating from NDE for small feedback loops, like using the data to put it into an AI so that the AI can at the end give us a better image interpretation or better classification of our defects. But we can also use the data coming out of our inspection actually to enhance the design. We can also use the data coming out of the service inspection to improve the operation. Or we can take them all the way back to the initial idea or the initial design. Now, that's just one of the value streams we have in our NDE 4.0 ecosystem. Another one, we are actually using equipment. We're using inspection equipment. That is, inspection equipment goes through a very similar, life cycle, value stream than what we have on our normal components we are inspecting. And for sure, we can take the data which we create during the inspection of our assets, we can use them for improving the equipment or even for recalibration purposes. For sure, we also need somebody to perform all those inspections. That's kind of a third value stream, all the way coming from certification, qualification, training, going over the experience and recertification. And again, here we can use that data we are creating during all our inspection, for example, for recertification purposes. And all of this really brings NDE from being this unnecessary cost factor to perhaps one of the most important data treasures for Industry 4.0. And this is why we really need data transparency. We need open interfaces. We need semantic interoperability. We need data security, and we need data sovereignty. Now, if you're interested more in this topic, I've already produced 2 videos, and you can find the links below it. And we have created an MOU on this topic, where by now, I think it's about 60 or 70 participants have signed how important they think this topic is. So for me, this is one of the keystones on the how of NDE 4.0. The second part for me That's reliability. We already talked about it, reliability of data. That's really one of the key information things we need. And Daniel Kanzler, yesterday, he had a really great talk about this topic. And last but not least, for sure, we need a lot of training and consulting to get into this world of NDE 4.0, to connect data science with NDE domain knowledge. And because I think all of this is so important, I started about a year ago a YouTube channel where I'm discussing about NDE 4.0, about different methods. I'm inviting guests, and I hope I will get a lot of speakers from this conference actually to appear also on the channel to give you more knowledge about NDE 4.0, where all of this is going. Besides, we have created already 3 special issues on NDE 4.0. One with materials evaluation, one with research in NDE, one with the Journal of NDE, and actually all the papers from this conference here will also be published in the 2nd special issue of the Journal of NDE. And if you out there have a paper about NDE 4.0, which you think is good, then please put it also in this one, because that call of paper for that 2nd special issue is open to everybody. Moreover, we will have the Handbook of NDE 4.0 available somewhere in summer this year. The same for a book we call the World of NDE 4.0. That's a book Rippy Singh and myself are currently working on. So thank you for your attention. I am really looking forward to hear all of your feedback later on in our panel discussion. So thank you for watching. See you soon and bye.